Hello, I'm Brian Young, and today we'll be looking at 26308 commercial electrical services. Now, in a commercial building, they're going to be using a lot more electricity than we do at home, of course. So they will probably have an outdoor transformer mounted on a pad somewhere around the facility. It's safer to have it outside the building in case something happens and you get an explosion. There are more often underground services, so they don't have power lines to contend with, and they're not an eyesore. You'll come into an electrical room where you might have 10 or 12 pieces of switchgear all bolted together in a long string of cabinets, 4 feet wide each. Each individual circuit breaker is known as a bucket. So each bucket will control some aspect of the building. It might be a couple of different floors. It might be a couple of different wings. They might have emergency panels. They might have high voltage. Lighting might be 277, 480, where 120, 208 is used for the receptacles and some smaller lighting, what have you. But let's take a look at 26308 electrical commercial electric services. And as always, they have trade terms. You should read through these trade terms. Cold sequence metering, they put a disconnect on the line side of the meter so that they can disconnect the meter and work on it. A service installation where the meter disconnect is installed ahead of the metering in order for power to be disconnected to allow for safe maintenance of metering equipment. Delta, we talked about Delta and transformers, service conductors. These are the conductors that bring the power from the utility. Service drop is overhead. The overhead conductors between the utility electrical supply and the service point. If it's underground, it's called a service lateral. So service drop is overhead, service lateral is under the ground. On page 1 on the right-hand column, just below the note, it says a building layout shows the location of the electric service and the location of distribution and branch circuit panel boards within the structure. Building layout. Receiving equipment, I don't have any highlights, but they're going to tell you that you need to inspect any equipment that arrives on the job. You don't need to inspect internal wiring. If an apparatus is delivered to the job and the crate it came in looks in good shape and the outside of the device itself, the apparatus looks in good shape, you don't have to inspect the internal wiring of that piece of equipment. We can take it on faith that the internal wiring is still intact and it's been delivered to the job. And over on page 3, the right-hand column, very bottom of the page, they're talking about metering. It says a self-contained meter installation refers to a single meter enclosure with a single watt-hour or demand meter. Most of the times, the meter will not have the full current flowing through it like at your house. At your house, the entire current that serves your house flows through that meter. In these commercial establishments, they will have a current transformer, a CT, and it greatly reduces the amount of current that goes through the meter. And that's all contained in the metering equipment or the meter cabinet. On page 4 on the right-hand side, first indented paragraph. Services rated 400 amps and above usually utilize a group of current transformers, one for each ungrounded conductor or set of conductors. Then here's the highlight. It says there are two basic types of current transformers, the bus bar type and the donut type. So we'll see an example of both of those, bus bar type and the donut type. Here's an example of the bus bar type. It's a bus bar and the entire current goes through that bus bar and the CTs are wrapped around the bus bar. The donut type is toroidal. It looks like a donut and it goes around the cables or the service entrance conductors that come in. Here they're demonstrating that the CT, the current transformer, is very much like a clamp-on ammeter. Clamp-on ammeters operate on the same principle as the donut type current transformer. It's actually measuring the magnetic field around that wire and interpolating how much current is flowing through the conductor to have that strong of a magnetic field. On page 6, on the right-hand side, metal wireways. Metal wireways are defined in NEC section 376.2 as sheet metal troughs with a hinged or removable cover for housing and protecting electrical wires. So it looks almost like a rain gutter, or sometimes, they're bigger than that, but it's a metal trough with a hinged or removable cover, and it contains the wires going to the service. Busways, they actually have bus bars inside the metal cabinet. NEC section 368.2 defines a busway as a metal enclosure containing factory-mounted bare or insulated conductors, which are usually copper or aluminum bars, rods, or tubes. Busways are used to provide a means of tapping the surface entrance conductors. So here's kind of an example of what it looks like inside of a busway. They have these these are bare copper bus, and they're running inside of this metal cabinet, and they're separated from the backplane by insulators, and you can tap onto them and take your power directly from them. Some of them have threaded holes where you can screw in circuit breakers. You can put a circuit breaker on here and use the screws to tie into the bus bar. You can see the neutrals up here on top. So black, red, blue, and then the white is the neutral. But that's what a bus bar is. Here's another example of a busway. It has bus bars inside of the metal enclosure. Over on page 8, on the left-hand column, very bottom of the page, last indented paragraph on the left-hand side, in accordance with NEC section 230.82.3, in accordance with NEC section 230.82.3. A disconnect switch connected to the supply side of the meter, cold sequence, must be rated at no more than 1,000 volts. Grounding and bonding. On page 9, left-hand side, very top of the page, NEC Article 250 covers the requirements for grounding and bonding electric services. Article 250 is the most important article in the code book. It is the one that will save your life. It also happens to be the largest article if you ever look at it. It's about 25 pages long, much larger than most of the other articles in the code book. Here down a little further on the left-hand side says NEC section 250.50 requires all grounding electrodes to be bonded together. So however many grounding electrodes you have on the job, you might have a pipe underground, you might have a cold water service, you might have a plate electrode or a ring electrode. They might put it around the entire building, or they might do corner deltas. Whatever grounding electrodes are present on a job have to be bonded together. All of the grounding electrodes on the entire establishment have to be tied together. High leg marking on the right-hand side of page 9, right-hand column, The conductor or bus bar with a higher voltage to ground in a delta connected four-wire system, also known as the high leg, is required to be durably and permanently marked with an outer finish that is orange in color. So high legs are orange, and it's also required to be the B phase. The center phase has to be that high leg, the higher to ground voltage. Here at the very bottom of the right-hand column on page 9, it says, note that this is the minimum for the lowest point of the trip loop and the weatherhead or the point of service. Clearances. You have to go to the lowest part of the drip loop for that clearance. So if it tells you 10 feet, the bottom of that drip loop has to be at 10 feet. You can't have it. For the service drop, should be a minimum of 13 feet 6 inches above grade. So the lowest point of the drip loop has to be 13 feet 6 inches above grade in a commercial establishment. Over on page 11, they have a couple of different examples of service entrance conductors. Installing commercial services, the most common service voltage for small commercial and other small loads is a 120/240 volt single phase 3-wire service. That's the same that you have at your house. A 120/240 volt single phase service is the most common for small mercantile, small stores, barber shop, nail salon, whatever you have. On the right-hand column of page 11, toward the bottom of the right-hand column, porcelain insulator attachments provide a separation between the service drop conductors, which may become worn and short over time, and other metal components. So you want to make sure that those cables are being supported off the building. You have to use insulators in order to attach them to the building. Now we get into a couple of different examples. Here's a service drop coming to a weatherhead, and there's your riser coming to a trough. This is a wireway. Off of that wireway, they will bring the metering equipment and the main disconnects for 3 slot stores. So this tells us, this is called a one-line diagram. This one line represents 2 2-inch conduits. They have 4 3/0 copper THWN. So they have 2 2-inch conduits coming down, and each conduit has paralleled 3/0 conductors for each of the ungrounded phase conductors and the neutral into this trough. And then the ground would be established here. Here's where they're establishing ground. They're going to go to their grounding electrodes. They're using a minimum of a number 2 copper to cold water pipe, a number 2 copper to the building steel, and another number 4 copper concrete encased electrode. So they're telling you what your grounding electrodes will be, and that you're going to tie the cold water, of course, and the building steel, of course, and they're going to have a grounding ring. It's going to be a concrete encased electrode underground, minimum of 2 feet underground. These are the different disconnects: 200 amp, 240 volt, 3-pole, NEMA 3R, that's outdoor, disconnect switch with 3 125 amp fuses. And here's a good example of that. Next time you're at a Dunkin' Donuts, you can, or any kind of a strip store, slot store, you can look and see that the incoming service looks like that they'll have that incoming service coming underground, and they'll come to a gutter, and then from there they'll come up to individual meters for different stores with a disconnect. So if you start looking, you'll start seeing those. On page 13 on the left-hand side, note that the NEC would not require a main service disconnect for the installation because there are fewer than 6 switches to disconnect power to the building. So if they have 3 of these, if they have 3 main disconnects, they don't have to, or 3 metering equipment and main disconnects on the sides of them, they don't have to have 1 main disconnect. Sometimes they choose to do that anyway, but you're allowed to have up to 6 main disconnects. So they're saying that in this installation, they would not have had to have a main disconnect. However, the service for the retail building was designed before any tenants were identified to occupy the building and provided flexibility to allow the tenant mix that could have required more than 6 disconnects for tenant services. So, because they didn't know how many tenants they were going to have, because they didn't know how large the stores were going to be, they did put a main disconnect in just in case they had more than 6 tenants. Over on the right-hand column, page 13, toward the bottom of the page, it says it's important to allow the manufacturer's requirements for torque to follow. I'm sorry, the manufacturer's requirements for torque when terminating conductors using mechanical lugs. So every screw, every bolt, every lug has a torque requirement. Even your spark plugs in your car have a torque requirement, and most of us don't follow them. We put our spark plugs in and we just tighten them down until we feel like they're not going to fall out. But they do have a spec on them, specification as to how many inch pounds or foot pounds that they need to tie in. Look, here's the busway that we were talking about before. It's a metal enclosure that has bus bars installed inside of the metal enclosure. That's a busway. Okay, here's another example of an incoming service. And again, here's the transformer out on a pad. This is a one-line diagram saying they have 2 3-inch conduits with 4 500 kc mil copper THW and conductors coming up into this busway. And there's the busway. And it comes up to each of these disconnects. They're cold sequencing. They're putting the disconnects before the meter so that they can turn off the main disc. They can turn off this disconnect and then they can service the meter safely. So that's cold sequencing. That's a good drawing of cold sequencing. Let's see what we have on the next page here. On page 16, on the left-hand side, switch gear. Figure 13 shows a switch gear, 480 volt Y, 277 volt. They tell you that it's Y. 3-phase service which is a typical industrial plant installation. So 277, 480, typical industrial plant installation. The Y is a good secondary because it doesn't have a high leg. So in situations where you're going to have a lot of single phase loads, ungrounded to ground, you want to have the ability to have an equal distribution of power even on the B leg, B phase. So you want to have Y so that you don't have a high leg. There's a multifamily service on page 21, left-hand column, close to the bottom of the writing. It says the service consists of a main fuse disconnect switch and meter stack connected with horizontal bus bars to the main disconnect. So here's their example. Here's their main disconnect. And look how long it is. That's because it has horizontal bus bars going into this meter cabinet. And then each of these meters is separately hooked up to the bus bar. Here's your main disconnect. You can't have more than 6 main disconnects. So here's one disconnect that disconnects all of these meters. And each one of these probably has its own disconnect switch, the main overcurrent protective device for the apartment. So here's 12 of them. They got 12 at the other end of the building. And there's a red label, a placard on the front of that main disconnect saying that there's another main disconnect on the other end of the building. This service complies with NEC section 230.72C, which requires that occupants have access to their own service disconnecting means. This exception allows the tenant meters and service disconnecting means to be placed inside the building under the conditions listed. Okay. So tenants have to have access to their own disconnect, their own main disconnect. All right, putting it all together. Let's read putting it all together. Think about it. It says, examine the services at your school or workplace. Is the service entrance properly installed and protected? Is the service entrance cable cracked or frayed? What about the electrical panel? Are the breakers properly labeled? Is there a main service disconnect switch? Yes, 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 and yes. Or no on the phrase. Um, because we're at schools, we have to comply with building codes, and they're inspected yearly. Fire marshal comes in and makes sure that everything's up to snuff. So we're very safe. We have a very good installation. In fact, at our campus, they just replaced all of the wiring a year ago. So we're all up to code. This concludes our discussion on 26308 commercial electrical services. If you have any questions, check with your instructor. And as always, work safe, work smart, and wear your PPE. It's there to protect you.